With that, we would like to introduce the interview session that will be moderated by Mrs. Edobong Akpabio, and the interviewee will be Mr. Guido. We would like Mr. Cohen to start a video that will give us an insight of what this interview session will be. It will be discussing the future of drones in agro-food across Africa and the world as a whole. Thank you.
Swarms of tiny flying robots are very safe, and they can open up a whole new world of possibilities, if they can fly completely autonomously. The main challenge in creating tiny autonomous flying robots is a limited weight and energy.
Here at the Micro Air Vehicle Lab, we've been working hard on overcoming this challenge. We've developed an extremely efficient navigation strategy to help us solve autonomous swarm exploration of unknown environments. This is the first time that such a complex task has been performed by a swarm of tiny robots.
Specifically, we created a swarm bug algorithm. Multiple robots fly off in different directions. Instead of mapping the environment, they deal with obstacles on the fly. When their batteries are at 60%, the robots fly back to a radio beacon at the ground station, again avoiding obstacles and each other.
Let's see the robots in action in the real world. To make the bug algorithm work, there are many elements to consider. The individual robot has to be able to navigate by itself in a very robust manner. The robot should also be able to sense and avoid each other and coordinate the exploration. The robots can carry an onboard camera to store images of the environment. No map, no memory, and no GPS. Just a simple solution to solve a complex task.
Here, we focused on search and rescue, but tiny flying robots could be really useful also in other applications. For example, in warehouses, they could track goods, or in greenhouses, they could monitor the crop. Exploration with swarms of tiny flying robots is very safe, and it opens up a whole new world of possibilities.
Thank you very much, Juan. It gives me so much pleasure to participate in today's webinar and to have the honor to interview Professor Guido de Croon. He's in the house already and preparing for this interview to give us a lot more information about what he's done and what he is doing. Professor Guido de Croon, you're welcome to our webinar this afternoon.
Hi, thank you very much. Glad to join.
Good to see you. Good to see you. Among the many things that that got me interested about your profile is the fact that you are a professor of bio-inspired micro-air vehicles. Such a wonderful name for drones. And that piqued my interest, really. And then it also says in your profile that you have developed a theory about how drones can determine distances. We're learning a lot more today from you. And then I also got to know that you have a personal goal, and that is to explain the many positive things that can be achieved with drones. So we are actually in the right place with you this afternoon to have you tell us so much about your work and all the things that we can get from our webinar today. Welcome, Professor de Croon. My first question to you. You've been involved in the research and technical development of drones. Like I got to know about the bio-inspired micro-air vehicles, which tells me that it has something to do with agriculture. The video also tells us that too. So please tell us about your motivation and the benefits of using drones for agriculture. And also we want to know the future. Is it going to be a dying technology, a dead technology very soon? What is the future of the drones technology? Professor de Croon, you have the floor.
Thank you very much for the introduction and your question. So, one of the things that really underlies my research is that a long time ago, when people talked about drones, they always talked about the 3 Ds, so dangerous, dull, and dirty. And I thought it has such a negative ring to it. So I want things that are functional, fun, and friendly. And so I thought of the 3 Fs basically, because I think that drones, of course, they can do these 3D kinds of tasks, but they can be useful in many other areas. And I think they can also, work along humans. And that is a very important thing. If you want them to fly, for example, in greenhouses or perhaps in orchards, there's also people there. And it was also already mentioned before that it's very important how this interaction with the humans is. And in my eyes, it starts with that the drones need to be safe. And one way to make them really safe is to make drones as light as possible as the task allows. So if you think about greenhouses, we're working on really pretty small drones. In the video, you saw extremely small drones. These drones were roughly 10, 12 centimeters in diameter, and they weighed 33 grams. But they were able to collaborate and explore an unknown space together. And the way in which I do this is indeed, like you said, I work on bio-inspiration. So I look a lot at how insects tackle their tasks. And insects are much more intelligent than we give them credit for often. So actually insects are still much more intelligent than our drones. And I just try humbly to approach that kind of intelligence with the drones. And in the same time, by doing that, we can keep the drones light and safe and still make them very smart.
Thank you very much, Professor. I was also looking to hear from you about the benefits of using the drones for agriculture.
Yes, so you saw a very nice example by Pat. It's actually perhaps interesting to say that Bram has a brother. He's called Sjoerd Tijmons. And he was actually a PhD student in our lab. So before he started the company, and he worked with me on intelligent small drones. And so PATS, I think, is one example, but another example in which I think drones can be useful in agriculture is to observe. It was mentioned the eye in the sky. Now, often we then think about very big lands where a big drone flies over them and takes pictures downwards. But I think that we work on that kind of application as well. But I think my work is tuned towards also bringing them closer to humans, closer to the ground. And this, on one hand, can be inside, so in greenhouses. At the moment, we're working together with a company called Royal Brinkman, and they basically provide greenhouses with technology. And our idea with them is to have basically multiple drones in a greenhouse that can fly and take pictures of the plant. And one of the first uses is to detect pests early. Pests and diseases, if you can detect them early enough, then you can take measures before it becomes a problem and before you have to throw away plants or flowers or it's often very hard to detect these because you have these ranges of plants where you cannot really walk in between. So a drone will be sooner able to notice this. And in that case, the drone is an observer. So it flies, it makes pictures. In first instance, it's going to send those pictures to experts. But these experts, they can indicate in the images, where are the diseases? Where are the pests? Where is the damage caused by the pests? And then after some time, you can have an AI, an artificial intelligence, that can do this automatically. And then basically, you have these tiny drones that fly around in the greenhouse. They gather the data. Then there's a cloud computer that looks at it with the eye of an expert, and which is available everywhere, all around the world, and which can give high quality advice. Although the hardware necessary at the place is actually not that expensive. If I'm talking too long, tell me. So, because there is
it's fine. It's fine. We're enjoying it anyway. Thank you so much. It looks to me from the panel discussions, I don't know if you observed that as well, that a lot more attention was focused on the benefits of the drones in production agriculture. A lot of what we saw in the video before this interview told us about what drones could do even in a warehouse, and for me that's major. Can we look at the benefits of drones in supply chain, agriculture supply chain? I mean, we know all about what it can do with data and what it can do with production. But what about the supply?
Okay, the supply chain. Yeah, so one part. So one part is indeed in the greenhouse, which we talked about. By the way, I think also in orchards that we're now in touch also with Italian farmers, where they, for example, have also diseases in olive trees, which are typically very old trees, and so it's really a huge waste if they die by this disease. Where these drones can fly around also there. So it's outside, but it's in between obstacles. If you do this, then you need the intelligence to be on the drone. So the systems we work on make the drone more intelligent in a cheap and light way, basically. Now, if we talk about the supply chain, then I'm sure that we didn't discover all the options yet, but one important one you mentioned is indeed in the warehouse. So you have these warehouses where you have very high stands, and it's sometimes difficult to keep track of the stock in those warehouses. And actually, sometimes when they do it, they have to close the whole place down. They have a few people on one of these high workers. I don't know how to say it in English very well, but it's this machine that drives, and then it goes up very slowly, and then the people, they go up with their scanners. But a drone can basically fly there much quicker, much more regularly. And importantly, if you make them small and intelligent like insects, then actually they are safe for humans. So you don't have to take extra safety measures. And so people don't have to walk around with like these very hard hats and safety glasses and I don't know what, because the drones are light and safe. So the normal operations can continue. Now, of course, it depends a bit on the supply chain. So if you talk about small cargoes that have to travel over land that is difficult to travel, then actually you could also use drones for that. So we work on drones that can take off vertically, transition into a plane, and then fly very far. And then when they arrive, they can land again. They can land autonomously, and so that they can transport small cargoes. But of course, I guess in agriculture, the cargoes are typically big. So in that sense, I think drones cannot be a solution there, to be honest. But it's something perhaps to inspire if you think about other applications.
Thank you very much. I know a lot of this, some of the information we're getting, and it seems to be an impression created that to use a drone is to have a drone. And we've been actually rolling around that because we believe that every activity in agriculture actually has a value chain. So with the drones technology, how would you stretch that value chain for us to understand that I can choose to play in a particular chain and not have to, do everything all by myself? What do you think, sir?
Okay, that's a very interesting remark. I don't know if I'm interpreting it completely correctly, but we had a company here in the Netherlands that unfortunately went bankrupt, but their idea, I think, was revolutionary. And so, although I think other companies now are pursuing this same thing, is to have drones in boxes at different locations that can be used by different users. And so suppose that you have multiple farmers in a region and they could use the same drone, but one farmer rents it on one day and it flies over that land. And then the next day, or even the same day, but in the afternoon, it flies over somebody else's land. If the police wants to use it because there's an accident, they can also reserve it, perhaps, And so you could have drones that are shared in property. Now, this is, of course, I think, mostly important if the drone is quite expensive. If you have a quite expensive drone system. My hope is that, but I'm not a businessman, so my hope is with these small drones, we make them very cheap. We always also join in competitions with other teams, and then so drone competitions, and then they come with a drone with lots of processing and very expensive sensors, and then the drone is like a few €1,000, and we typically bring a drone that's around €200, and we prefer to put something of $40 on it. It's still not super cheap, but it's already much cheaper than the other drone. It makes the task of autonomous flight harder to have it cheaper, but it makes it more available to everybody. And that is actually what we focus on, and so that even the cheapest of drones can actually do very intelligent behaviors for which you now have to pay quite a lot of money. And so on the one hand, I think drones can be shared if they're more expensive. On the other hand, I think that we should also work to solutions that are actually pretty cheap in terms of drone hardware, and that do not require somebody to be an expert to use it. It should be really an intuitive interaction with the system, and the drones should basically hide all the complexity from the human.
Yeah. Thank you very much, Professor de Croon. I just have one question for you, and that is something we've been discussing in-house in the African Farmer Stories, and wondering, okay, how do we kick off this drone we'll have a kind of timetable for us to be able to demonstrate the use of this drone technology.
Sorry, I was muted. So your question is, how should we kick it off?
Hello, Professor de Croon.
Yeah, sorry. Okay, I'm gonna. Shall I try and interpret it as how we can kick it off? Okay, this.
Okay, so I think we lost Mrs. Akpabio there, but what?
I'm here.
Okay, we didn't get your question. The network went a little bit off.
Okay, sorry. I was asking the prof about the suitable pilot project to demonstrate the workings of the drone technology.
Yeah, that's a very good question. What to start with? Personally, we started with, like I said, together with Royal Brinkman, with a project to observe plants. PATS started very enthusiastically with, the fighting of these insects, and for both applications, there are still doubts in the sense that, especially around the economical model, in a sense. I think that those doubts will disappear. But it's obvious that we're still early, let's say, in the technology curve, where we're now in the same time developing things. And PATS is making a product, so they're a bit further, and we are doing more research, let's say. I think that we need to show working systems, let's say, and I think that if you take a system now the way it is, it may not yet give all the advantages that you will get from it in the future. But if we don't do it now, then we never get to that future. So we need to get started on multiple things. On our side, that's like in the application side, it's observing plants. In terms of technology, as a university, we work on the fundamental techniques that will allow many applications. So from warehouse stock tracking to flying in orchards to flying in rough areas, finding a landing place, for example, things like that. So I think just doing and just taking initiative and making it possible wherever it is in the world.
Thank you, Professor Guido de Croon. It's been lovely talking to you. I know there are lots of questions in the Q&A chat box, and Cohen will be attending to that. You have a lot of questions there. So over to Cohen. Thank you very much, Professor de Croon.